We're going to wrap up this first unit on the y86 with a fairly detailed discussion about how all these instructions are implemented. So let's begin with the first stage, or fetch. And we'll ask the question of each stage, what do we have to do? And what parts of the processor are going to be involved in doing that? So for the fetch stage, our goal is to read an instruction from memory. And some of the questions we might ask are like, well, how big is an instruction? Because we have instructions of different sizes. And then once we have the instruction, we're going to need to break it up into pieces. So the parts of the processor that'll be involved in the fetch stage are clearly the program counter, because that tells us where the instruction is, the memory, because that's where we get the instruction, and then there's going to be some new pieces like computing how much to change the PC, and also some logic to identify invalid instructions potentially. So let's begin. We have memory and we have a program counter. And what we're going to do is we're going to use the value in the program counter to read something from memory. And then we'll take what's in memory, and what we'll do is we're going to load it into an internal register called the instruction. So in all the pictures that follow, we'll use these dark blue boxes for processor state. These are things you've seen before. The sort of rounded boxes are going to be logic that we have to design. And then the ovals are going to be internal registers. Now, instead of just reading the instruction into one big register, what we really want to do is we want to break it up into a bunch of pieces, because we know that the opcode or the I code is going to be crucial in determining what instruction we're executing. And then depending on what instruction it is, we might also need the function. Many instructions will have registers, RA and RB, and some will also have this quad word value that we're going to call val-c. So when we read from memory, we're going to populate these registers. And then, based on the opcode, that will tell us exactly how many bytes we needed to read. And based on that opcode and how many bytes we needed to read, we're going to figure out how to increment the PC and produce a potential next PC value, which we'll call val-p. Now, why do I say potential next value? Well, the reason I say potential is that sometimes we have jump instructions or call instructions, and that will mean that we actually go to a location different than val-p. So from the PC, we use that as the address into memory. We read out the instruction, we populate these registers, and we increment the PC. And that's our fetch stage.